Welcome to my channel Online Technical Mentor. In this video, I will discuss one of the combinational circuit, that is encoder. Here I will show you or introduce the encoder circuit, its operation and working. Now, encoder circuit converts one set of digital signals to another form. It has a relationship between its input and output. Let's see the definition of encoder first.
Encoder is a combinational logic circuit which performs the conversion of one signal set into a group of signals of another set. This process is known as encoding. It accepts as input 2 to the power n or less input bits and produce n outputs. As I have already said that the encoder circuit converts one set of signals to another form. But the last line, follow the last line, it's very important. It accepts 2 to the power n or it may be less than 2 to the power n input bits and produce n outputs. Now look at the block diagram of encoder circuit. Suppose this is an encoder circuit. Now if it has n output, then it must have 2 to the power n inputs. That's why we can name this encoder circuit as 2 to the power n cross n encoder circuit. Suppose you have two outputs, then there must be 2 to the power 2 or 4 inputs. Now, if the encoder circuit has 3 outputs, then it will have 2 to the power 3 or you can say 8 inputs. One more thing, you have to keep it in your mind that for an encoder circuit, any one of the input will be logic 1 at a time. That's mean when any one of the input becomes high or becomes logic 1, then rest of the input will remain in the 0 state or in the low state. Now look at an example. Let's design a 4 cross 2 encoder circuit where 4 indicate the number of inputs and the value written at the right hand side of the cross, that is 2, indicates number of output. So this is the block diagram of 4 to 2 encoder where there are 2 outputs named as x and y, and as per the definition of encoder, it must have 2 to the power 2 or 4 input labeled as D0, D1, D2 and D3. Now let's write the truth table. So this encoder circuit has 2 output x and y. And what are the possible combinations of x and y, since it deals with 0 and 1 only? So xy may be 0, 0, 0, 1, 1, 0 and 1, 1. Now the inputs are D0, D1, D2 and D3. There are 4 inputs. You can also write D3 over here, then D2, then D1, D0. Orientation is not a problem. You can write in any orientation. As I have already said that for an encoder circuit, any one of the input will be logic 1 at a time. So when D0 is 1, the rest of the input will remain in the 0 state. And for that combination of input, we will get x and y 0, 0. So for the next combination of input, when D1 is 1 and rest of the inputs D0, D2 and D3 are 0, we will get 0 and 1 for x and y respectively. Next, when D2 is 1 and the other inputs are 0, then the encoder circuit will produce 1, 0. And for the last combination of input, when D3 is 1 and the others are 0, then xy will be 1, 1. So this is my truth table. And from this truth table, we are now going to derive a Boolean expression. Obviously, there are 2 outputs, x and y, so we will get 2 Boolean expression through which we will design the logic diagram finally. To derive a Boolean expression, you have to consider the output. Since there are two output x and y, so you have to consider the output one by one. So first consider the output x, the x column. When D2 is logic 1 or D3 is logic 1, then x are becoming 1. When either D2 or D3 are becoming high, then only x are producing high output. So you can write like this: x equal to D2 or D3. So when D2 or D3, any one of the inputs are becoming high, then only the x are becoming high. Similarly, for the y output, look, the second row and the last, that is the fourth row, are becoming 1. So when the y outputs are becoming high, look, when D1 is high, look parallelly left. When D1 is high or D3 is high, then only y are becoming higher. So that's why you have to write like this: y equal to D1 or D3. That's mean when D1 is high or D3 is high, then only y will become high. Now this is your two Boolean expression derived from the truth table. Now you have to draw the logic diagram by looking into this two Boolean expression. Now what you have to do, you have to first consider the variables, input variables, which are present at the right hand side of the assignment operator. That's mean D1, D2 and D3. D3 is present in both the Boolean expression. By looking into these input variables, you have to draw the connections. That's mean D1, D2, D3 line first. Since D0 is not present on either expression, so D0 is optional. You can write D0 in your logic diagram, you may not. It depends on you. So it doesn't matter whether you write or not. For the first Boolean expression, x equal to D2 or D3, that's mean you have to draw connections from D2 and D3 line and make an OR operation in between them, just like this. So draw the connections from D2 and D3 and make an OR operation, since there is a OR operation, and you will get x as an output. Similarly, for the second expression where y equal to D1 or D3 is written, that's meaning you have to draw a connection from D1 and D3 and make an OR operation in between them, and you will get a y. So this is the logic diagram of 4x2 encoder. Now check with the truth table whether it's satisfying our truth table or not. So first consider the first row. What it is written, D0 is 1, and for that combination of input, x and y are becoming 0. Since there is no connection of D0, you can also write D0. It doesn't matter. If D0 is high and there are no connections drawn from this line, so x and y will remain in the 0 state. Now the second row of the truth table, where D1 is 1 and the rest of the inputs are 0. For this input combination, we are getting x as 0 and y as 1. So now when D1 is 1, that's mean this line D1 is 1. The downward OR gate is attached with this D1. That's mean whatever may be the other inputs, since one of the input of OR gates are becoming 1, y will become 1 and x will remain in the 0 state. That's why we are getting this output 0, 1. Now for D2 connection, when D2 is 1, so where is the D2? Look, this is D2. So from this D2 line, the upward OR gate has a connection from this D2 line. That's mean x will become 1 and y will remain in the 0 states. That's mean we will get x as 1 and y as 0, 1, 0. And for the last row, where D3 is 1, this is the D3 line. Both the two gates has a connection from this D3 line. That's why both are becoming 1. That's why the last output is 1 1. So by using this encoder circuit, we can now design octal to binary encoder, BCD encoder, priority encoder, etc. So all this encoder circuit will be elaborated or explained in separate videos. Subscribe to my channel Online Technical Mentor and press the bell icon for latest update.